side note there. But all right, welcome back, everyone. I won't take more of the time. We'll be talking about how to navigate the hub and share our own models here. Not me, Wade will be talking about that. So you're in good hands. Wade, please take it away.
All right. Everybody can
As
see my,
another reminder, please keep the questions coming in the chat. I'll keep monitoring them.
yeah. And I'll try to make sure to stop every so often. If I don't, just feel free to yell at me. Everybody can see my screen over here.
Yes.
All right, cool. Okay, so we're going to go ahead and start with session 4. And again, remember the structure of the Hugging Face course is they're essentially releasing 3 it's one course, but there's going to be 3 groups. And so we're finishing up the first group today. And I think each of them are going to be like 4 sections. And before we get into it, just want to make sure everybody has all this information, the study group registration page. As Sonia said, we're only going to have one more session next week. And that's where we're going to be looking at folks who have submitted blog posts or applications using the train transformer or compete in the SST2 challenge. Will hopefully be willing to share their work. We do a walkthrough and do a Q&A and get feedback from folks in the group on that work. But yeah, here's the resources again, depending on where you're starting. If you're in fastai, the fastai course and Zach's walk with fastai is a good place to start, as well as the fast book. And there's a reading group that Amon's doing over on weights and biases. It's going really well. I see a lot of people blogging about what they're learning there. So check that out. I think he's like at chapter 6 right about now. And then the fastai Hugging Face libraries, which we saw last week, Adapt NLP, Fast Hugs, and Blur. Give those a go. Find out what works for you. Try building something using one of those, or look at the source code and build something yourself. That's a really great way to learn more about how fastai callbacks can be used to basically train something like Transformers library. And then for ML data science in general, you got the Chai Time Data Science Podcast at Weights Biases. So check all that stuff out. And by the way, Sonia promised next week to announce where he's going. So if for no other reason, come back for week 5 to find out where Sonia will be in the future. Okay, so agenda, we'll be looking at section 4. And this is probably kind of one of the easier ones to go through. And we'll probably go through this much quicker than last week, where we did the demos of the 3 fastai libraries. But essentially what we're looking at in section 4 is how to use Hugging Face, their model hub, how to find data sets to train models on, and then also how to find good pre-trained models to start with. And so we'll be looking at that, and we'll go through that process of picking a data set, picking a checkpoint, and then training. And then the final part of section 4 is about sharing models. So we'll actually go through how to share a model on the hub and all the particulars with that. There's 3 ways they cover. We'll actually do a demo of probably the simplest and most straightforward way. And again, the deadline for competitions is Tuesday, August 3rd, 12 p.m. Pacific Standard Time. I will probably be lenient. Right now, we have none. So if you want to win some good swag from Weights and Biases and get some respect and also be able to demo your work, this is a great competition. It's really meant to be fun and to enhance your learning. So I hope that folks will participate in one of the 3 competitions. And here they are again. Best blog post, best results on SST2, and also no cheating. And then also most interesting application of a fastai train transformer. And you can send a link to your blog post or to your Colab notebook, or just to my email at wgilliam@omeow.com. Any questions coming up on the competition, Sonia?
No, not yet. If I may, I just wanted to add that to people listening and who will be watching this later, these things really are pretty helpful. Like I know many of the people tuning in are really starting their journey. But as someone who's found his career start through all of this stuff, do blog and do participate in these competitions. Weights and biases recognizing you for an achievement really goes ahead and says something on your resume. So all you have to do is just send an email to Wade, and if it's too bad, he won't mention. If it's good, he'll mention it. So it's a win-win anyway. So please consider participating. That's what I'm trying to say.
Yeah, absolutely. And the other thing is that if you participate and send something in and are willing to share, we're also willing to give feedback. And so, I'll be providing feedback. I'm sure Zach, Morgan, other guys, Arto, Sonia, other people in the community. So, one of the hard things is we're all especially with being virtual, it's hard to get feedback from other people and to actually work together. And so this is a good opportunity to actually get some feedback on what you're doing by participating in one of these competitions, or all three of them. Okay, so let's get into section 4. So the first part starts with using the hub, and essentially the Hugging Face hub is a place to find data sets, find models, pre-trained models to work with. And the other thing that's kind of interesting to note is that the models in the hub aren't limited to transformers or NLP. And so you're going to see a lot of other third-party folks pushing models, and there's text to speech, there's speech recognition, there's vision in there. So it's kind of growing. So it's not just, NLP transformers. It's a place for sharing any type of model, which is actually really cool. And essentially, to get on the hub, you just go to huggingface.co, and the model hub is really, I guess, technically this part right here where you go to models and you can search by task. You can look by data set, languages. You can just type in if you know a certain data set like SST, you can go ahead and just search for it on here. And then the nice thing is once you're here, you can go ahead and look at it on GitHub. You can explore the data set, which will kind of give you a GUI to actually look and explore and page through the data. And you can click this button right here, which will tell you exactly how to load it using their data set API. And then, so that's actually, I'm sorry, that's the data set side of things. I got navigated over there. But on the model side, you can go ahead and look at things by category, task, language, same type of thing. And, click in, actually read a little bit more about, how it was trained, what the data looks like. People, not always, but on some of the bigger data sets have done a really good job at listing known biases or known kind of potential issues. So definitely, depending on what you're using, you want to go through here and see what the authors of these models or data sets have actually said about what they've actually created before you start training yourself, so that you kind of know maybe limitations and potential issues. So that's essentially what the hub is. Now, oops, that's not what I wanted to do. So the first thing that we'll look at today is using pre-trained models. So again, probably the most important thing is to find a data set that's suitable to your task, that's kind of as close as possible to what you're going to be doing. So today, we'll look at a demo, and let's imagine we're doing sentiment, positive or negative sentiment on something like concerts or whatever, or music. We probably want to find a data set that's looking at something similar, and if possible, that's actually already targeted for a sentiment task. And as one person found out in the forums, when you look at pre-trained models that are trained on a specific data set, like, for example, SST2, you can't just use them and adjust the labels for something other than 2 labels. And so if you look at the forums, there's a discussion, because one of our users found that out and was surprised that they tried to start with a SST2 trained classification model, and tried to then change it for from 2 classes to 5, and it basically said no, it can't happen. And that's the reason, is that these pre-trained models, when they're trained on specific classification tasks, Hugging Face doesn't just chop off the classification head and put a randomly trained one. It basically gives you whatever the user trained it for. So just be aware of that if you see things like that. But in our case, if we're actually training a sentiment model with 2 labels, we could go ahead and use a model like that and fine tune it. So yeah, find a data set that resembles what you're trying to do, and then also try to find a checkpoint that's suitable for your task. So best practices here is after you have your data set and checkpoint, is to use the auto model, the auto tokenizer, auto config for classes. That'll make it a lot easier to iterate over different architectures if you want. And then, as I said before, when you're using a pre-trained model, see how it was trained, understand the data sets it was trained on, its limitations, its biases. That will go a long way in helping you stay out of trouble when you're actually using these things. So with that said, we're going to go through that process that I just outlined right there. And so we'll be sharing this notebook later. So I'm going to start with the usual, just installing transformers, data sets, and I'm going to use Blur for this demo since that's the library I created and I'm also most familiar with, but you can use adapt or fast tugs as you choose. And let's go ahead and do all the imports. And so step 1, right, is to find a data set suitable for your task. So I mentioned that, potentially let's think of like doing like, sentiment for different songs or whatever, right? So I do know if I go to the model hub, since I'm doing sentiment, I already kind of know that there is a model called IMDb that would allow us to, that does sentiment on movies. And so that's pretty similar to what we're trying to do. So I can just search for IMDb and it pops up there. I could read through and see like exactly how is it, what's the data look like? It has a label, it has a text. I can look at the splits between the train, the test, or validation, and then there's an unsupervised test, so with no labels. And it's still missing some information, but I'm going to go ahead and go for it. And so just by clicking use in dataset library, I can go ahead and what I'm going to do is just grab the string you pass into load dataset. We'll go back here, stick that in there. And then as we saw last week, loading a data set is as easy as calling load data set from the datasets library. And then we can go ahead and print out what it looks like. We can look at one of the rows in the training set, and then we can also look at the features so that when we actually set up prepare our data and actually get ready to train our model, we know what we need to do. So let this run. Hopefully it doesn't take too long. And while that's going, the second step is to find a checkpoint suitable to our task, right? So I'm going to go back to Hugging Face. I'm going to go to models. And for this example, I'm actually going to try to find I'm going to try to use Distilbert. And I see that there is a Distilbert based uncased fine-tuned SST2 English. So this is already doing a text classification and it has 2 labels. And if you're competing in the competition, you already know that. So, and this may be one you want to explore if you're doing the competition. But since I am also going to be training a model that has 2 labels, right? 1 or 0, positive or negative, I'm going to go ahead and just choose this model right here. And again, you click Using Transformers, and I'm going to copy the name of the checkpoint. And I am going to go here and put that in there. And then this is something you kind of saw last week where we just prepare the data set. I'm going to let this train for a little bit, and we're going to go back to the slides. But I did want to note the one thing you'll see here that's different than the examples last week is that I'm using this random subset splitter. And that is because the training corpus is pretty large, and it would probably take like an hour or several hours to actually train on this data set. And since we don't have that long and no one wants to sit there and watch my progress bars spinning around for 3 to 4 hours, what you can do is use this fastai splitter. And what you do is you specify how much of the training set do you want to randomly include. And so I'm saying here 10%, and how much of the validation data set do you want to randomly include? So I'm saying just include 5%. And not only is this a good way to demo things in a timely fashion, but if you're experimenting and you just want to make sure that your data blocks are set up right, your learner set up correctly, it's good to start with a small subset, kind of go through that first to make sure all those bits are working before you let something train for a long time, only to find out it breaks once it gets to the end of validation. So I'm going to go ahead and just start this stuff right here, and then we'll come back to it. Any questions coming up yet, Sonia?
Nope, none so
All
far.
right. So it's clear as mud, right?
If
All
I
right.
can understand, I'm sure everyone can
All right,
understand.
that's good. That's good. Yeah, if you don't have any questions, I feel good. So, okay. So now we use the hub to find a data set, find a checkpoint, and now we're training. So after we're training, the next thing that we're going to do is actually want to share our model with the world, right? And there's 3 options presented in the course. And really after this, go through if you haven't gone through the course yet, you should really go through all the course videos and get an idea of, because there's a lot more details about how these things all work. But essentially there's 3 options to share your models. One is you can use the push to hub API. And this is probably the simplest option. And essentially what you do is on your model and tokenizer object, you call a method called push to hub. So if you're using transformers, you have this, and you essentially say, this is my model name. And when you do that, it will actually go through the process of creating your repo on Hugging Face and pushing the necessary artifacts for folks to use your model. So we'll create the repo. And again, the repo is just a Git repo. That's all it is. And so you use it and it works just like Git. And probably every single person here is familiar with how Git works. And so how you work with a model you've pushed to Hugging Face is exactly how you'd work with any other project you have that is version controlled by using Git. So this kind of automates the whole process of putting everything up there. And I think this is kind of the recommended option. Like I said, super easy to use, and we'll see this in the demo next. Another option is using the Transformer CLI. And the steps are, there's a little bit more manual steps. So you log in with the Transformer CLI or the Hugging Face CLI. Again, if you have installed Transformers, the CLI is available to you. The Hugging Face CLI is something that you'd have to download separately. I don't know too much about it. I think it actually gives you probably greater superpowers. So if folks want to chime in and have played with it, I'd be interested to hear your feedback. But yeah, once you log in, the next thing you do is you create your repo. And then once that's created, you're going to upload your model and token artifacts, just like you would anything else to Git. And then the third option is using the web interface. And if you go to huggingface.co new, and then assuming you have logged in, you basically can create a repo there. And then you can actually clone that repo locally, or clone it on uh, Colab or whatever. Train your model, and then we saw like in I think week 1 or 2, where to actually create those model and token artifacts, you just call save pre-trained, and so you call save pre-trained on your model, your tokenizer, and then once you have those, you're going to use git to you actually need to do a git add dot to add all those files, commit them, and then push them to the repo that's created right here. So it's a little bit more manual, but you also have a lot of control, and you can do a combination of both. So once you've used the push to hub, if you need to make changes, you could go ahead and git clone your repository, make changes, and then push those artifacts up there. So I'm going to go back here, and looks like my LR Finder. Yeah, that's kind of weird. Let's see if it trains here. So I don't know if Zach's on the call. I actually had some issues with LR Finder yesterday doing something similar. And so I'm not exactly sure what the problem is here, but if he's on here, take a look, Zach. I think this is your code. If not, I'll find you on Discord.
I don't see Professor.
The professor's not on here.
No.
Okay. I'll find him later. It's just something recently I noticed that sometimes I get these errors, and sometimes I can rerun LR Finder and it works. And so it's kind of a mystery to me as to what's going on. It could be because of the random subset I have. Like maybe there's something with that. That's my guess.
Yeah, I would just shuffle it again. Sometimes it breaks for me, and I would just like rerun the random splitter again, and then it'll work. So might be that.
Yeah. Like I had something, and this is a good kind of like FYI for folks, is where I was doing a random subset to get things going quickly. And the random subset wasn't capturing all the classes. And it took me a while to figure out. That's why I put this learn.dls.c, because sometimes it was giving me just one class, because that's randomly I have a very small subset. So it could be something with that. So LR Finder might be fine. It might just be me.
Also, to understand how LR Find works, Aman is doing an awesome study group. You can find more details there. We won't dive into that.
Oh, cool. Is he doing that this week, or did he already cover it?
I think it'll be in the next chapter, if I'm not too wrong.
Awesome. If you talk to him, what would be cool is to actually see, because LR Finder doesn't always work great for transformers. Like I noticed that the general principles of how you choose the learning rate, I typically go further back from what it says for transformers, and it generally works better. So maybe I'll join that and ask him some tough questions on transformers, and we'll see how good he is.
Let's do that.
So anyway, so we're going training. So we got F1 score of 0.8, basically almost 0.9, and 0.9 on accuracy. You can look at the results. Did pretty good. And so now we want to share. So if we look at, so this is my account. I don't have any models or data sets shared so far. And again, to be able to share, you have to have an account on Hugging Face. And the first thing, as I mentioned, we're going to do the push to hub approach, is we have to call transformer CLI login. And again, since we obviously are using transformers, we have this. There's nothing additional you have to install. You just need to log in, and it actually then creates a token and stores it for you, so that you can actually push things to the repo that's created. The other thing is you want to make sure that you have Git LFS installed. So Git LFS is used for managing larger artifacts. So I think anything over 400 megabytes. And so obviously, depending on some of these models, you're going to see some pretty large, like PyTorch.bin files, which is your model weights. And so you want to use, make sure that this is installed either here in Colab or in your own system so that those things can get pushed correctly to GitHub. So I'm going to go through and just make sure that is installed. And then I also notice that I usually have to set these two items, my username and email. Just so you know, it's not going to push to your GitHub repo when you do this, but it needed this information in order to actually be able to share things correctly. So I'm going to go ahead and set both of those parameters. And then in Blur, I have this get blur TIFM, and it's nice because the blur transform, whichever one you're using, has access to all the Hugging Face objects. And so, as I mentioned earlier, is that in order to push to the hub, we have to push the model and tokenizer artifacts. And so blur TIFM gives us access to both the model and the tokenizer. So that's why I grabbed it. And so what we're going to do first is call this, and I am going to create a pre-trained model called session 4 IMDb model. I also noticed that when I'm using Colab, I have to pass this use temp directory. I'm not exactly sure why. I don't know what it does, but other folks on the Hugging Face forums notice this as well. So let's go ahead and start this process of pushing our trained transformer to Hugging Face. And it's really this easy. It's these 2 lines of code. And it's running. I'm going to go back here, hit refresh. So you can see actually it created the repo right there, right? And if I go in here, you can see like now you can use, well, not quite yet, but you can see that this is just a Git repo. And you can see it added my PyTorch model that's pretty big. The configuration, it has Git attributes file in here. And so that takes care of the model. And then now we need to upload the tokenizer bits. So again, on the Hugging Face tokenizer, we call push to hub, and the name of our model that we want to share with the rest of the world. And refresh here, and you can see that now all the tokenizer bits are in here as well. And so this is something that you can actually use. So any of you that wants to use my WGPub session 4 IMDb model, it's now available to the entire world here. It was really that easy. And to show you just how easy it is to use, once you have a model up there, you can just click using transformers, just like we did earlier when we were looking for a good checkpoint to start with. And we could copy and paste the name of our pre-trained model, go here, and we could actually use it. So here I'm just going to use the pipeline. Remember, we did a text classification model. There's the name of my checkpoint. We could go ahead and run that. It downloads everything, just like for any other transformer. And then hopefully if we built something that's decent, we could go ahead and say, oh, this song really sucked. And it gives us a negative score. So it's that easy to actually share and then be able to use the models from the hub. Any questions on any of that?
There's a question from earlier. So Ravi's asking, how do you, let's say if you want to use a transformer for image classification and you're not sure where to start, how do you pick that model from the hub?
You know, definitely, I'm not the one to ask. I really have more experience working with the NLP transformers. So good question. I would hit up the Hugging Face forum or Twitter and ask folks kind of, if you know what task you're looking to accomplish, let folks know like, hey, I'm looking to use this. I want to use Hugging Face. I want to try one of the vision transformers. Anybody have any, good links to tutorials or how-tos? But yeah, I don't know myself. Maybe someone else here on the group could answer that question
I can
too.
I can chime in. So if you've just been like, you don't need to read the paper. If you've been following Twitter, you would know that, let's say, convert is used for blah, or some other transform is being used for blah, and it's sota, or it was sota. So if you can just recall those names, those are a good start. And if you don't remember those, just try to search on archive sanity, or even archive for that matter, and you should be able to find the paper, and just start from there, and you can go from there.
Cool. Anything else?
No, that's it.
All right. So that's pretty straightforward. So as you're building these things, oh yeah, just a couple other quick notes. Make sure you got Git LFS installed, or you're going to see interesting errors pop up, and sometimes they're not super informative. And we already kind of covered that. And the only thing that I didn't do that's discussed in the course is to build a model card. And essentially, that's just the README markdown file that's at the root of your Git repository on Hugging Face. And essentially, you want to include as much information you can as about how you trained it, the results you got, if there's any known issues with the model potentially, or the data set it was trained on. You want to share that information so that folks starting with your pre-trained model know the same information that you hopefully got from the pre-trained models you started with ahead of time. So if you look at the Hugging Hugging Face course, there's a last section on building a model card that shows you kind of an example of all the bits to include. So as you share stuff, take a look at that and try to do that. And you could build the model card just through the web interface too, which is really nice. With that, so homework is to watch the official course videos from week 4, train and share a model on the hub, and please consider entering one or more of the following competitions: best blog post, best results, most interesting application. Deadline is August 3rd. You could email links to your work directly to me. And next week, we will be looking at what folks have presented, hearing about where Sonia is going, and doing a general Q&A. So anything that anybody wants to talk about with regards to the course, transformers, fast AI, using those in combination, we will cover all of that. And that's all I have for today. So pretty straightforward. If there's any other questions or things that folks want to talk about, let's do it.
There's a question by Martin. How would we implement the Ulmfit approach with Hugging Face transformers?
So you really wouldn't. So that's a whole separate. So the Ulmfit uses an LSTM, so it's a recurrent neural network, and transformers work entirely different. It's entirely different architecture. So transformers is kind of built on this attention mechanism and being able to run things in parallel, whereas Ulmfit is built on a recurrent neural network, or an LSTM. And so the whole model, how it's trained and how you actually get predictions, it's different. Now, what you could do, which would be interesting, is if you look at the fast book, is like we have this competition on SST2. Do a train 2 models. Train one on a state-of-the-art transformer model, and train another model using Ulmfit, and present your results and see how they both work, if they're comparable, or if one's better than the other. Do some investigation and try to figure out why that is potentially.
Follow-up question on that. Would there be no benefit in trying to fine-tune transformers on a specific corpus with its specific language?
Would there be, say that again?
Sorry, would there be no benefit in trying to fine-tune transformers on a specific corpus with its language?
I wouldn't say there's no benefit. If you have a transformer that's trained, so if I understand, I want to make sure I understand the question, is that if you have a transformer that's trained on a specific language, is it worthwhile to fine tune that on your own data set in that language?
Martin, could you
Sonia,
please
sorry,
clarify?
can I? Yes, yes. So my question is, I mean, Ulmfit, as far as I understand it, one of the advantages is that if we have a very specific data set, like, I don't know, book titles or recipes or something like this, we can take a general kind of a model trained on general English language, fine tune the language model on that specific data set to learn more about the structure, and then on top of that, fine tune a classifier or whatever we want to achieve.
Right.
And so my question is, can we do the same kind of Ulmfit type structure for transformers as well? Kind of take a general English language transformer, fine tune it on recipes or something, and then train a classifier on that.
Yep. Yeah, actually, in principle, they work the same. It's just that the language model, in ULMFit is based on an LSTM, and then after you have that model, they put a classification head on top of it, and transformers work the same way. So all transformers, regardless of the downstream task, whether it's task classification or named entity recognition, all of them start with a language model. And so you could actually take that language model or take any of the language models, fine tune it just like you would with ULMFit. And then using that language model that you've even fine tuned on your corpus, then use it for classification or named entity recognition or whatever. So in principle, they work the same. They're just different architectures, but they work exactly like ULMFit, where you can do that same type of process if you want.
Okay, thank you.
Yeah, yeah. So you could even kind of like what we did here, you could actually train like a mass language model, like with BERT, and actually kind of how we went through the process of push to hub, but we could use the save pre-trained methods. And then once we have that, we can go ahead and use that model as the basis for text classification in the same way that we saw like in the demos over the last 4 weeks. And Hugging Face will add that classification head for us, and then we can train our downstream classification task.
I've shamelessly shared a link to a summary I had done of a paper. So this is not for transformers, but it's titled An Embarrassingly Simple Approach for Transfer Learning. What I'm trying to allude here is these tricks might also work. A few of these tricks would work really nicely with transformers. So I could talk about them, but it's really straightforward. So those might also be worth exploring, because I haven't seen any such discussion with transformers as well. The authors basically talk about how should you use exponential decay with learning rate, and so they also talk about an auxiliary loss when you're trying to do transfer learning. Again, I'm going on a tangent here, but I think it's relevant. So if you've pre-trained on a certain task and you're doing transfer learning, so they talk about auxiliary loss. You have your original loss when you're fine tuning, and you add an auxiliary loss, and you sort of account for both of these things to make sure that the network works really well. When you stack a few layers on top when you're doing transfer learning, so you would want a different loss for that, and the original loss parametric for the original network. So that's what this paper talks about, and it's just experiments around those, when you should do that, when you shouldn't.
Oh, that's cool. Yeah. No, thanks for sharing. I wasn't even aware of that. So that's awesome. Actually really cool.
Awesome. I don't see any other questions, so maybe you can wrap up early.
Yeah. I saw one down at the bottom about training scenarios that favor ULMFit over transformers. I just
Yes.
pulled up the
Yes,
chat.
I'm sorry I missed that. Yes.
Yeah. And so back in the day, just anecdotally, I remember folks saying that on certain classification tasks where the text is rather short, that they had better results with ULMFit than using a transformer. That was a while ago, and there's just been so much development in terms of transformer architectures. Like there's so many, I don't know if that's the case anymore. And a good test would be to actually maybe find some short text corpus that's labeled and train ULMFit on it, and then choose like one of the more state-of-the-art transformer architectures like Roberta or dBERTA, and see what the results look like. to me, I typically just use transformers, and I haven't seen where Ulmfit is outperforming um, using a transformer in just my work, but it's not, by any means, comprehensive. I haven't tested all, variations of playing with Ulmfit and playing with, every single transformer architecture. I typically use Roberta or like dberta, and the results are as good in my experience.
Awesome. I think that answers the question. There's
Cool.
another one. Any thoughts on using transformers on computer system data, like making a machine sentence or document from a machine's event, then train a transformer over it to predict anomaly events or next word? So are you trying to do language modeling, just to be clear on the question, or what are you trying to predict here?
So like instead of making sentences from normal sentences, normal words, English words, make sentences or documents from let's say systems binaries. Let's say calculator.exe uh, executes makes network connection to this IP, or writes make a did a write event on the system, or let's say chrome.exe launched and then did 100 network events, then did 50 disk write events, something like that, and then train a language model over it to predict what will be the next event. And if let's say the next event is deviated from the regular events, then mark it as an anomaly or things like that.
Yeah, I think it reminds me of Sonia is in the fast book and the fast AI course. I think it's like in the first chapter where Jeremy was showing like creative approaches for vision.
I was
And
just going to say that.
yeah,
Yes.
yeah. And so like he shows like you could take like an audio clip and convert it to a visual representation and then run it through a CNN. And then he actually did something similar to what you're talking about, which was um, he actually there's an example of where they're looking at computer viruses and converted those to a visual representation, and then was
So
using a
they mapped how the person moves a cursor around
oh
on a
yeah,
login screen or something like that. And when it's a bot,
yeah,
like there are very specific patterns that the model can pick up, and that became like a huge success for the person at their company, and they actually deployed it. So there's like this is an interesting project for you.
yeah. I think definitely go for it, because I mean really if you can turn anything into a sequence of text, is you could conceivably do exactly what you want to do, and use transformers to create a language model behind it, and then actually then build downstream tasks. So I think that would be an interesting entry for the competition, just saying. So but yeah, I think that would work.
Just one more follow-up on here. So
Please.
in this case, I cannot use any pre-trained models, right? Like because my system events would be like the vocabulary would be very different than the English words.
Um, if you follow Sendex, so he shared, I don't remember the name of the model, but that was trained on GitHub data.
Mm.
So he's like trying to open source Copilot in his own way. That might be a good start. Usually, it's a good start to like just pick up a pre-trained model, because you don't want it to like learn how the language is structured at all.
And the other thing is, even if the LM you start with isn't super related to what you're looking at, is really it's giving you a starting point, and then you can train it to one degree to another, right? So if it's more, if the pre-trained language model you start with, the data set is a lot different than your data set, you just maybe are going to have to train it more and spend more time training it. But like Sonia, I'm saying, it doesn't hurt to start with something, even if it's not exactly representative of the text you have.
Mhm. Okay.
I think we have 10 minutes, so I could, as a suggestion, just like do a paper summary of the paper I'd shared, because I think it's interesting and it'll make for like a good experiment or project for people who might want to submit along that, if that's okay with others.
dictionary.com.
Oops.
Noun.
You've activated my Google, Sonia, so.
I'm sorry, there's a question. Let me quickly read it. Oh, it's a suggestion. You can check that link out by Srinivas.
Oh yeah, that's a good link. I've looked at it a few times. So that kind of goes through like the whole process of building a language model and then applying that to, I think, a classification task. So yeah, that's a nice resource.
Okay, should I do the paper summary if it's helpful?
Yeah, go for it.
Awesome. Could you
Here,
please let me share? Yeah.
Yeah, let me stop my share. All right, go for it.
Awesome. So the series, and this was a 2-year-old blog post, so please forgive me. I'm pretty sure I would forget the details, but it's called 5-minute paper summaries. I'll try to summarize this in less than that. The reason I'm talking about this, even though the paper is slightly dated because they just talked about RNN models, but it should be helpful for just like general experiments, and you could literally do the same experiments and write about transformers, which I know I haven't seen any such posts. I might not be following everything. So again, the paper is called an embarrassingly simple approach for transfer learning from pre-trained language models. And for context, this was around the time when these was just starting to pick up. For further context, like using pre-trained language models wasn't common at all in NLP. Jeremy and Sebastian Ruder actually showed us through the Ulmfit paper that this works really well. It's not just for computer vision. Surprisingly, it was just being used for computer vision. Now we use it for pretty much everything in NLP and even beyond for GANs as well. So at that time, the authors, Alexandra et al., showed how you should apply transfer learning, and they were sort of comparing their approaches and calling them embarrassingly simple. I talk about transfer learning in this post. I'll skip that because I'll assume everyone knows what transfer learning is, but you're just trying to utilize a model and use its domain knowledge or whatever it's been trained on as a starting point. So you don't have to waste all of that computation. There are 5 model details that the authors say are important, and these address 3 issues. At that time, transformers are much more computationally expensive, so this did not age well at all. Sophisticated training techniques, again, let's say it did not age well with that as well. And catastrophic forgetting. I would say with transformers, I think it's still there because you need further more data, like for most of them. So these are still active issues. But here's the approach. I spoke about using an auxiliary loss. But on the left is the LSTM model. Reminder, this was at the time when LSTMs were all the rage. They were the SOTA models. So on the left, you can see the pre-trained model, and it's learning how to say quick brown fox jumps, whatever that sentence is. And now you're adding a linear layer to, let's say, do a different task. So the first suggestion is using an auxiliary loss for that and using the loss for the original model as well. Because this has been trained in a certain way, and you would also want to make sure that you don't, when you're fine tuning, you're also changing these weights inside of H1, H2, and all of these hidden layers. Sorry, W1, W2, these weights are being changed, and you wouldn't want to change them too much. So how do we account for that? They call it Seattle, or they called it Seattle. It's called, these steps are called single step, auxiliary, loss, and transfer. So first of all, they train a language model, a word level language model, pretty standard at the time, hasn't changed since. And they add an auxiliary loss. So loss isn't simply loss of the task. It's also plus gamma. I typed Y because I was lazy and I don't know how to type in LaTeX. Y times loss of the language model. So you trained the language model and now you're fine tuning it. You've added the task specific layer. And the trick here is using exponential decay of Y. This Y that I just mentioned, you're exponentially decaying it. And logically, it makes sense because when we add these layers, so these few layers, Y1, Y2, Y3, and YT, right above the linear layer. These are untrained, right? So these are randomly or initialized with some level of smartness weights. You initialize weights with different methods. That's a complete different discussion. I'll skip that. But these are untrained, and you would want to guide them and eventually exponentially decay that. So that's why we are exponentially decaying it. The other thing is sequential unfreezing. If I remember correctly, this was also there in the Ulmfit paper. But the argument here is these few layers closer to the input. So earlier layers in the network, earlier means closer to the input, are trained really well. And the one towards the output, not so much. So first you would want to train the outer bits in the image, the one on the top, followed by these, followed by these. So you're sequentially unfreezing them and training them bit by bit. You could also apply differential learning rates. fastai does that. So you could account for, hey, you know what, these layers, they are like word language models and they do the job pretty well. So you wouldn't want to change them too much, maybe a little for your task. So that's another trick you could try. And I think that's about it. They talk about optimizers. I'm pretty sure Adam is a more common one than SGD. Again, this paper was a while ago. That's why when we say that the field moves really fast, it's quite fast. And then they talk about how they compared against Ulmfit, and the results were pretty interesting. And I did that so I failed myself. I did that in 7 minutes. But are there any questions around this?
I don't see any questions, but that's actually a really interesting approach right there. And it looks pretty easy to implement. So basically, if we go back to, if you scroll up a little bit to the loss visualization. So if I understand this right, you basically do a cross entropy loss on the LM, right?
Yes.
And then you add that to the cross entropy loss if you're doing multi-classification multiplied by this gamma parameter that's decayed over the course of your training. Yeah, that's super cool. Exactly. It makes sense too. It's amazing how easy some of these ideas are. Initially, when you bring up like, oh, taking the LM loss with the classification loss, it sounds like, oh my gosh, how does that work? And it's really as easy as loss plus gamma times loss. And that's it.
Yeah,
that's cool.
That's why Papers with Code is such a cool website. Like, I hope they get better at it, but if you could just, like select a equation inside of a paper and literally see the code pop up, like that would be so cool, because I also like really suck at understanding what does that equation mean.
Yeah, that's cool. By the way, someone in chat asked if we could extend the August 3rd deadline to Thursday. And I just said, sure, why not? So the deadline is now Thursday.
Awesome. Okay. Since there are no further questions, maybe you can wrap up. As a reminder, there are 3 different tracks that are open for submission. So please consider submitting, and thanks for joining. We'll see you all next week. All right. Bye, everyone. Thank you. Thanks for joining.
Yeah. Thanks, Sonia.